Today's subject is impulse. So Unikitty and Batman are coming toward you. Who is harder to stop? Unikitty or Batman? So let's see. The momentum of Unikitty is 3 times 1 is 3. And the momentum of Batman is 90 times 1, 90. So Batman has more momentum, so I say Batman is harder to stop. But how do you stop Batman? In order to stop Batman, you have to apply force. And so this means that you are changing its momentum. So a change in momentum created by a force over time is called impulse. Impulse is a change in momentum. So if the momentum in an object changes, either the mass, the velocity, or both change. If the mass remains unchanged, which is often the case, then the velocity changes. And so what occurs? There has to be a momentum change. Remember, acceleration is a change in velocity. So what produces acceleration? A force. The greater the force acting on an object, the greater its change in velocity, and therefore the greater its change in momentum. So how long the force acts is also important. If you apply a brief force to a stalled car, you change the car's momentum. If you apply the same force over an extended period of time, you will produce a greater change in the momentum. So the longer time you have to sustain that force, you produce more change in momentum. So both force and time are important in changing momentum. So for example, boxers attempt to move with an opponent's punch when it is thrown. In other words, a boxer moves in the same direction as their opponent's punch. This movement may prevent a knockout blow being delivered by their opponent. Explain how. So, if the force applied by the opponent's punch can be extended over a longer time, then the force of the blow is reduced. So for example, on the left picture, there's no time. It's very short. You get hit straight on, and you feel a greater force. Now, if you were to roll with the punches and you give more time for that person to extend their arm, the less force you feel, and the more you have chances to survive this match. An egg dropped on a tile floor breaks, but an egg dropped on a pillow from the same height does not. Why? Again, in both cases, the mass and velocity are the same. In this top example, if the amount of time the object is in contact with the force goes up, then the amount of force goes down. When you drop it on a pillow, the egg starts to slow down as it touches the pillow, and the pillow increases the amount of time it takes for the egg to stop. So what is the purpose of these barrels? Again, we're dealing with, for example, if there's a car crash and it hits one of these, it would slow down the amount of the time that it takes to crash. In physics, the quantity force and time is known as impulse, Ft, force. And remember, delta t is a change in time. So impulse is a change in momentum. And so this is how it looks like on your chart. We say J is for impulse, and it's force times a change in time, which is also equal to mass times a change in velocity, because mv is momentum. So another way to say that formula is Ft, force is in Newton, times in second, which is impulse. And this equals mv2 minus mv1. So when we do calculations, we might use the entire equation as shown here, Ft equals mv, or we might just use the left side, which is J equals Ft, or the right side, J equals m, Vf minus Vi, depending on what variables are given and what they're asking us for. So for example, a net force of 25 newtons is applied to a 20 kilogram cart for 2 seconds. What is the impulse? So they're looking for J. Okay, so impulse, they give me force, they give me mass, and they give me time. Okay, so I can work with the left side of the equation. So J equals Ft. Okay, so 25 is our force, time is 2, so our impulse here is just 50 newtons per second. What is the change in momentum? So the change in momentum is also 50. And so how do I know that without even doing calculation? How would I know that? Well, if you remember, we said, and make sure you write this on your notes, impulse is equal to a change in momentum. So anytime they ask for a change in momentum, they're asking you for impulse, or if they're asking for impulse, they're also asking for a change in momentum. A net force of 30 newtons, so that's my force. Start writing your units down. Is applied to a 10 kilogram cart, so that's my mass. That is already moving at 1 meters per second. That's my velocity. So that's my initial velocity. The final speed of the cart was 2 meters per second, so that's my final velocity. How long was the force applied? We're looking for t. So on the left, I have my variables down. We're looking for t again. And so we have all these variables and I have initial and final. So we're going to use the entire formula. Ft equals m vf minus vi. So 30 times t, because we don't know what t is, equals 10. And my final velocity is 2. Initial velocity is 1. So we have 30t equals 10 and t is equal to 0.3. So in order to get 0.3, I did 10 divided by 30, which is 0.3. A 0.05 kilogram ball is thrown from rest with a force of 40 newtons. So from rest, that means my initial velocity is 0. That's my mass, and that's my force. If the force acts on the ball for 12 seconds time, what is the final speed? So it looks like I'll be using the entire equation again. So F, we just plug in our numbers. So here's our formula, and we plug in for each variable. Force is 450, time is 12 seconds, mass is 0.045. I don't know my final, that's what I'm looking for. And my initial velocity is 0, so we can just cross that out. So this becomes VF times 0.045. 450 times 12 is 5,400. To get VF by itself, I have to divide both sides by 0.45, and that cancels this out. So this divided by 0.045 gives me 120,000 meters per second as my final speed. A 0.5 kilogram frisbee, so that's my mass, is thrown from rest, so initial velocity is 0, to a final speed of 12 meters per second. What is the impulse of the frisbee? So they're looking for J. Okay, so J, remember, so we're taking the right side of that formula. J equals mvf minus vi. My mass was 0.5, my final velocity is 12, initial is 0, so 12 times 0.5 gives me an impulse of 6 kilograms per meters per second. So a tennis player hits a ball during a tennis match. Compared to the magnitude of the impulse given to the ball, the magnitude of the impulse given to the rack is, when is the same? Remember, we have a conservation of momentum, and a change in momentum is equal to impulse, so impulse has to maintain the same.